NCERT Chemistry, the first lesson, Unit 1, Solutions. What are solutions? Sugar solution, salt solution, copper sulfate solution. In sugar solution, the sugar is a solute and water is a solvent. Salt solution, salt is a solute and water is a solvent. Now consider the solute copper sulfate dissolved in a pure solvent water. Solute plus solvent gives a solution, copper sulfate solution. Solution is a homogeneous mixture of two or more than two components. Homogeneous means uniform throughout. What is uniform throughout? The composition and properties are uniform throughout the mixture. The substance which is present in a larger quantity is called pure solvent. The smaller quantity is called solute. The solute is the substance which get dissolved in a medium is called solvent. The solute is a substance which get dissolved in a medium, solvent medium is called solute. So, solute plus solvent solution, it consists of two components, solute and solvent, called binary solutions. In this video, we are going to see the concepts related comes under the binary solution. Depends upon the physical state of the solute and the solvent, solutions are classified. Gaseous solution where gas is the solvent medium, liquid solution where liquid is the solvent medium, solid solution where solid is the solvent medium. The physical state of the solute varies. First one, gas in gas. Atmospheric air is the best example of gas in gas, the mixture of oxygen and nitrogen gas. Liquid in gas, chloroform mixed with nitrogen gas where liquid is a solute and medium is the gas. Solid in gas. What is the example of solid in gas? Is dust particle in air medium is the best example of solid in gas. Camphor in nitrogen gas is example of solid in gas. So, these are all example of gaseous solution. And liquid solution and where solvent is the liquid, gas in liquid, oxygen dissolved in water. Liquid in liquid, milk is an example of liquid in liquid. Example, the fat liquid is dissolved in water medium. Solute is the fat and water is the liquid. Here what gives an example is ethanol dissolved in water is given as a example. And solid in liquid, glucose water, glucose dissolved in water, example of solid in liquid. Eosin dissolved in water gives the ink. Paint also example of solid in liquid, liquid solutions. So, the example of liquid solutions are given. The next example is solid solution where solid is present in a medium. Gas in solid, solution of hydrogen in palladium. Liquid in solid, amalgam of mercury with sodium. Solid and solid, copper dissolved in gold. And in the alloys, the mixture of metals, solid metals are also example of solid solutions. So, these are all the examples of solution, different types of solution where gaseous solution, liquid solution and solid solutions. Methods of expressing concentration of the solution. A dilute solution and a concentrated solution. What is dilute solution is 5 gram in 250, 5 gram of solute in 250 ml of water, 25 gram of solute in 250 ml of water. The solution which contains less amount of solute is called dilute solution. The solution which containing more amount of the solute is called concentrated solution. So, there are proper methods which expressing the concentration of the solution. There are various methods: mass percentage, volume percentage, mass by volume percentage, parts per million, mole fraction, molality and molarity are the different methods expressing concentration of the solution. First, we are going to see mass percentage, W by W. Mass, what is mass percentage of the solution is, the mass percentage of a component is mass of the component in the solution divided by the total mass of the solution into 100. For example, 10% of glucose solution means 10 gram of glucose in 90 gram of water, total gives the 100 gram of solution. So, this is 10% glucose solution. So, this is helpful in industrial chemical application. Commercial bleaching powder is contains 3.62 mass percentage of sodium hypochlorite in water. It may be of 100 grams. So it's used in measurement in industries. So mass percentage is the mass of the component in the solution divided by the total mass of the solution into 100. The component with the solvent gives the total weight of the solution. Next one is what is volume percentage of the solution. V by V. Volume percentage of the component is volume of the component by total volume of the component into 100. For example, how to calculate this volume percentage of the component is, for example, 10% of ethanol solution means 10 ml of ethanol dissolved in 10 ml of ethanol dissolved in 90 ml of water gives the 10% of ethanol. The total gives 90 plus 10 gives the 100 ml of the solution, that is 10% of ethanol. The 35% of volume of ethylene glycol used in antifreeze in automobiles, in car for cooling engine. The ethylene glycol 35% by volume of ethylene glycol used as antifreeze in automobile because of this antifreezing property. The antifreeze lowers the freezing point of water to the minus 17.6 degrees Celsius or 255.4 Kelvin. So the substance used in antifreeze agent in automobile radiator is ethylene glycol. To the temperature, to the what temperature it lowers means this minus 17.6 degrees Celsius, in Kelvin 255.4 Kelvin. The next one is what is mass by volume percentage. The mass by volume percentage is useful in medicine and pharmacy. The mass by volume percentage dissolved in the how much mass of the solute dissolved in 100 ml of the solution. Next one is parts per million, ppm. What is ppm or parts per million? That is, if the solute is present in trace quantities means number of parts by parts of the component to the total number of parts of all components present in the solution in 10 to the power 6. Here in the case of concentration, parts per million can be also expressed as mass to mass, volume to volume and mass to volume. The sea water, 1 liter of sea water containing 1030 gram, otherwise it can be expressed as 6 into 10 to the power gram of dissolved oxygen. Such a small concentration can be expressed as 5.8 gram per 10 to the power 6 gram of sea water. Otherwise it can be expressed as, the 10 to the power 6 can be expressed as 5.8 parts per million. It is useful in the expressing the concentration of the pollutants in water and or pollutant in atmosphere, the parts per million, or is often expressed in terms of microgram per liter or parts per million. So parts per million clear. The next we are going to see what is mole fraction. What is mole fraction is the mole fraction given by the symbol X. The right hand side, the suffix of subscript of the right hand side X denotes the component of what. For example, the mole fraction of the component can be expressed as number of moles of the component by total number of the moles of the component. For example, XA, given substance A and B, the mole fraction of A can be calculated by number of moles of A divided by the total number of moles of A and B. The total number is A and B. So, number of moles of A plus number of moles of B. In that, what is the percentage by composition of number of moles of A, that is XA. Now, consider the solution containing I number of components. The mole fraction of I is Ni by the total number of moles. So, Ni by the summation of Ni. So, total number of x1, x2, x2 is equal to the sum of the given solution, the sum of all mole fraction is unity. The mole fraction is relating to the sum of the physical property of the solution. Say for example, the vapor pressure with the concentration of solution are quite useful in describing involving the gaseous mixture. So, mole fraction is number of moles of the component divided by the total number of the component. So, in this page what are all the expression we have seen is mass percentage is the mass of the component solution divided by the total mass of the solution into 100. volume percentage of the composition is volume of the component by total volume of the component into 100, and mass by volume is the mass of the solute dissolved in 100 ml of the solution. What is parts per million is number of parts of the component by total number of parts of all components in the solution into 10 to the power 6. What is mole fraction of the component is number of moles of the component by total number of moles of all components present in the mixture. Next we are going to see one worked example for the calculation of mole fraction. The question is calculate the mole fraction of ethylene glycol C2H6O2 in solution containing 20% of ethylene glycol by mass. So 20% of ethylene glycol means the remaining is 80% is in the solvent medium, that is water. Now we have to calculate what is 20% ethylene glycol moles. So 1 mole of ethylene glycol formula is CH2OH CH2OH C2H6O2. The 1 mole of ethylene glycol weighs 62 gram. 1 mole of ethylene glycol, the molar mass of ethylene glycol is 62. So 1 mole of ethylene glycol is 62 gram per mole. 62 gram per mole means what is 20 gram of ethylene glycol? So 20 gram of ethylene glycol mole is 0.322 mole. So 20% ethylene glycol, remaining is water. What is number of moles of water present in that mixture is 1 mole of water is 18 gram, that is 80 gram of water is 4.444 moles. So ethylene glycol is 0.322 mole, number of moles of water is 4.44 moles. So the mole fraction of glycol is 0.322 in total number of moles. The amount is mole fraction of ethylene glycol is 0.068. So what is the mole fraction of water is? The mole fraction of water can be calculated by 1 minus that ethylene glycol, that is 0.932. Otherwise, number of moles of water divided by the total number of moles present in that mixture will give you the 0.932. So mole fraction calculation. Next one is what is molarity? Number of moles of the solute present in the volume of the solution in liter is called molarity. For example, 1 molar, so for example 0.25 molar of sodium hydroxide means 0.25 mole of sodium hydroxide dissolved in 1 liter. 0.1 molar solution of sodium hydroxide means 0.1 molar, that is the 10 gram of sodium hydroxide dissolved in 1 liter. So that is molarity, number of moles of the solute present in 1 liter of the solution. Next one is calculate the molarity of the worked example. Calculate the molarity of the solution containing 5 gram of sodium hydroxide in 450 ml of the solution. 1 mole of sodium hydroxide, gram molecular mass of sodium hydroxide is what? The gram molecular mass or 1 mole of sodium hydroxide is calculated as sodium, oxygen and hydrogen, that is 40 gram. So 1 mole of sodium hydroxide is 40 gram, 5 gram of sodium hydroxide is 0.125 moles. So the 0.125 mole of sodium hydroxide present in 450 ml. So according to molarity, the number of moles of the solute present in 1000 ml. So 0.125 mole of sodium hydroxide present in 450 ml. If it means for 1 liter means what will be the molarity? So will give you as 0.278 molarity. 0.278 moles per liter or 0.278 moles per decimeter cube, measured in decimeter cube. So the calculation of molarity of a solution. Next one is what is molality? What is molality is here the molarity per liter of the solution, the molality is per kilogram of the solvent. Molality is number of moles of the solute present in the 1000 gram of the solvent or 1 kilogram of the solvent. For example, that is 1 mole per kilogram of potassium chloride means Potassium chloride molar mass is 1 molar is 74.5 grams, 1 mole. So, 1 molar solution of potassium chloride means the 74.5 gram of potassium chloride dissolved in 1 kilogram of water will give you that molality of the solution. So, each method is expressing the concentration of the solution its own merits and demerits. For example, mass percentage, parts per million, mole fraction, molality are independent of temperature, whereas molarity is the function of temperature because the molarity per liter of the solution, the volume depends upon the temperature. The volume molarity depends upon the volume, depends upon the temperature, and the mass does not. So, molarity calculation varies with the temperature. As the temperature varies with as the volume depends upon the temperature. So, molality is moles of the solute in mass of the solvent in kilograms. 1 mole per kilogram of potassium chloride means 1 mole 74 per gram potassium chloride dissolved in 1 kilogram of water. Calculate the molality of 2.5 gram of ethanoic acid in 75 gram of benzene. 2.5 gram of ethanoic acid. Ethanoic acid, methane, ethane, ethanoic acid, C2H4 and O2. The calculation is 60. So, 1 mole of ethanoic acid, molar mass of ethanoic acid is 60 gram per mole. So, the moles of ethanoic acid, mole of how many moles of ethanoic acid present in that mixture is 1 mole is 60 gram, 2.5 mole is 0.047 mole of ethanoic acid. Mass of benzene is 75 gram. So, solvent 75 gram to the 1 kilogram or 1000 gram is how much will be the molarity. 0.417 mole of benzene present in 74 gram. For 1 kilogram or 1000 gram, what it will be the molality? The calculation will give you the molality, that is equal to 0.556 mole per kilogram. So, calculation of molality. Mass of the solute in 1000 gram or kilogram of the solvent. So, molality is mass of the solute in 1000 kilogram, so 1000 gram or 1 kilogram. Molarity is the mass of the solute in volume of the solution in liter. As the volume depends upon the temperature, molarity varies with the temperature. The next one is mole fraction, number of moles of the component by total number of moles of all the component present in the mixture. The next one is parts per million, number of parts of the component by total number of parts of all component present in the solution. Mass by volume and mass by mass and volume by volume. Thanks for watching. Subscribe for more videos. Thank you.